Okay, so I think this is the last Tuesday. So by the end of the method in constant coefficient, we are going to have our solutions kind of depends on the factors in auxiliary equation, which is the m1, 2, and 3, and 4, and how many m we have. It really depends on that. And I think to apply this general solution, we could go just to check the example, how to solve the question. So remember that in the constant coefficient, we have three cases. Okay? Three cases. The first one is when the roots are real and distinct. The second case is when we have the same root, the multiplicity. The third case is when we have a complex conjugate. Okay, and let me get through the example. So today's my plan is finishing off this example and getting introduction for undetermined coefficient, and hopefully the big idea will be also can be delivered today. And next Tuesday, finishing the undetermined coefficient, and we still have at least 2 or 3 more techniques. So whenever we finish these techniques, after that we are going to have the midterm. So the midterm will be the 2-hour class. Okay? The 2-hour class. So Tuesday. So it can be next 2 weeks, or 3 weeks. Okay? Depends on when we finish the chapter. But if we finish maybe in the middle, we need to go through, then the next class we need to move on to the next chapter. So the next Tuesday after that will be midterm. So yeah, we could start from examples now. Okay, and I think many students not coming because they got COVID. they got infected each other. Yeah, they said that from roommate and then it's spread out. So I think if you get also just take care and check your, maybe using Rapid if you want. Okay. Okay, let's take examples. Solve this equations. So now we have the third order. Okay. So all the constant coefficients in our case here, they are all will be homogeneous, okay? Because that is the way we are getting the auxiliary equation. So when we have this, we could get this order as our power for our auxiliary m. Okay? So we can have m cubed plus 3m squared minus 3m. So it's minus 4, sorry. M cubed. This is 3m squared, and then this is negative 4. Okay. And this is equal to 0. And we are going to find the root. Okay. Find the root. And how to find the root? Okay. If you remember, in the polynomials, we could get the root from, so let me write the possible roots is, let's say, if you remember, I'm usually using this p over q. Okay, so p over q, which is factor of 4. This is factor of 1, or we could just ignore that. So factor of 4 means that this is plus minus 1, plus minus 2, and plus minus 4. Okay? And factor of 1 is plus minus 1. So we could check plus minus 1. So I think because it's only 1 with lower, we can check plus 1, negative 1, plus 2, negative 2, plus 4, negative 4. And also to narrow our solution, we could also check with the card rule. I don't want to review that. Maybe it's too long. But let's say that the card rule is if we have a polynomial, let's say a PM. The Descartes rule is just to mention that if we have the signs like this, change of signs, so we are going to have one positive roots, and we can check the other way around for the negative m. So this will be negative. So we have 1, we have 2. So we have 2 negative roots or 0 negative roots. Okay, the way we are doing this is because it's a polynomial of 3 degree, so the total of the roots should be 3. So which means that if we have, because this is only having one positive root, so it should have this root. It is one positive root. It must have. So it can be 1 plus 2 negative roots, and it becomes 3. Or probably we have, well, I think we don't have any other choice. So I think it should be 1 positive root and 2 negative. Sometimes some equations, they might have the complex root, the rational number. So because we have 1 positive and 2 negative, so we could start with all positive number from 1 to 4. So we could check that and use the syntactic division. Right? But I think because it's very simple actually, you could check one by one, okay, because it's not too complicated. But if, for example, the equation is really long, maybe it's too complicated, maybe it's power of 5 or power of 4, it's really complicated, right? To narrow our roots, we can use all of it. Okay, so now the next thing we can do is checking through the syntactic divisions. Okay. So syntactic division. So let me write syntactic division for polynomial is going to have 1, 3. It's supposed to be 0 because it's supposed to be having m, and then negative 4, all the coefficient. And then the roots that we want to check is, let's start from 1. This is 4. 4 multiplied 1 is 4, so 4 here, 4. Oh, I think we get the first zeros or the first roots. So if this is 0, then 1 is our root. Okay? So this is the positive root that we have. So the next thing we get, we can check the negative root, or you could check from here, and you could rewrite the equations. So we could write the equations as x minus 1 or m minus 1, and then m squared plus 4m plus 4. Okay. And I think we can factor out this. It becomes m plus 2 squared, right? So we have m minus 1 and then m plus 2 squared. Okay, so the m, let me write here the conclusions. The m1 is 1, m2 is equal to m3 is equal to negative 2, and it's correct. 1 positive 0, 1 positive root, and 2 negative roots. The 2 negative roots have the same value, negative. And because of multiplicity, we are also regard this negative 2 as 2 different m2 and m3, but it has the same value. Okay, what's next is to write our general solutions. Okay. So general solutions, let me write here, general solution is y. The first one is e with power of m1 x, which is 1, so it's just x. And for the m2 and m3, remember, if we have the same value, to make the equation or to make the components linearly independent, we need to multiply with x. And if we have, like, for example, 3, we need to multiply again with x. So x squared, x cubed, and so forth. So we are going to write this plus c2 e negative 2x, and then plus c3. So instead of negative 2x, we need to also multiply the c3 with x. So x e negative 2x, okay? As long as you can see the pattern, how to write and how to solve this auxiliary equation. Because most of the question will be this kind of type, this kind of question. So the first one is this m equal 1. The second and the third is when the roots are the same value. So we are going to write and adding this x to make it linearly independent. What happens if we have 3? 3 they have the same value. The next one will have x squared. E will follow it. Okay? So it has the pattern, and I think it is quite easy to follow the pattern. Okay, now the next example, let me get it through okay, we have this. So the question is solve this and find the proposed solution. So case 1, case 2, case 3, they all can appear in one equation. So as long as we can arrange, tailor the general solutions, and you can see the pattern. That's the most important thing. Okay? If you need to see the pattern, So we can start this by taking this into maybe writing in more clear sense way like this. will be helpful. And we could take this as our auxiliary equations with m, 2m squared plus 1. Okay. And then this actually can be factorized, right? It can be factorized. We can factorize this and make it m squared plus 1 squared, like that. Okay. And this equal to 0. And the m squared plus 1 equal to 0 is, this is basically an irrational, right? So we could have the m, let me write here, m is plus minus imaginary number, right? So we are going to have how many m? How many m's will we have? How many? 4, yes, 4. 4 because we have squared. So squared, we have 4. Okay. So these, the 2m is imaginary number, the other 2 is the negative part. Okay. So let me write m1 and let's say equal m3. Okay. The number 2, 4, it's up to you. Okay. As long as we consistent from the start to the finish. Let's say this is our m. So from what we have in our notes, okay, if we have this complex conjugate, okay, we just have the component of imaginary numbers, which means that the alpha is 0 and beta is that positive 1 and negative 1. Okay? So we could say this alpha is 0, beta is 1. Now we could tailor first the general equations from y. And from what we have in, I think I've also in your notes, we can rephrase this components with the cosine and sine through the Euler formula. Oh, I forgot to add x because it has the same, right? Don't forget that. Okay, I forgot. Sorry. So it should be adding x to make it linear independent. So this is the first two. The 3 and 4 we could write x going outside like that. We could write x and then writing all the component with cosine x and sine x. So at the end, the general solutions, we could write that this will be c1 cosine x plus c2 sine x. This is because alpha is 0. This is because alpha is 0. And we just focus on the beta. And then plus c3x cos x plus c4 x sine x. How to get the cos and sine? It is from the formulation the last Tuesday, the Euler formula. I believe we don't really need to memorize that because I think you can later write down in your notes. And in our midterm, we are using our one paper notes. Okay, one paper notes. So you could write anything that's important. Okay. Well, I think everyone has different priority. Which one is the difficult? Which one is easier? So I believe you can handle that. Okay? You can figure out which one is your weakness, and you could put it on your notes. Okay, now the next example. Solving 3y third order 5y double prime plus 10y prime minus 4y equal to 0. Okay, you could refer to the first example. Okay, we could try to find from the possible factors, possible ratios, and then narrowing using if you want to use the Descartes rules, or directly just checking the roots, checking the roots using the synthetic divisions. That's also possible. That's possible also. Remember, in the complex conjugate, if alpha is not 0, we will see the e to the power of something. E power of something. This is because alpha 0, e to the power of 0 is 1, so we erase all the e. Okay, so for this part, okay, let me give you a couple of minutes just to try out this one. Remember that at the end, it might involve more than one page. You can see that later at the end how the end will look like. So this is basically polynomial problem that you need to solve. So some methods in polynomial will be very useful here. If you still remember how to solve the polynomial, this will be really useful. Warm up yourself. Yeah. I think this from here. Sign is negative. Oh, it's the same. I think you can check your notes. Okay, it's the same formulations. So we could just focus on the value. Okay, so we could write this as 3m cubed plus 5m squared plus 10m and minus 4 equal to 0. And we could write down the possible roots, okay, possible roots. This is the factor 4 and factor 3. So we are going to have plus minus 4 plus minus 2 plus minus 1, and then divide by plus minus 3 plus minus 1. So we are going to have plus minus 4 plus minus 2 plus minus 1 plus minus 4 over 3 plus minus 2 over 3, and then plus minus 1 over 3. Okay, now to narrow our roots, maybe we check the Descartes rule. So let be m. So we are taking that we have one positive root, and when we have negative m, we have 1 and 2. Okay, so two negative root or 0 negative root. So if it's having 0 negative roots, it can also possible that the roots is not negative, not positive, which is imaginary. Okay, that is another overview. So we could have this one positive root, two negative root, or one positive root and two imaginary numbers, or two imaginary roots. Because the number of the roots should be equal to 3, because we have the third degree of all numbers. Okay. So after we get this, we can take out the synthetic divisions. So take 3, 5, 10, and negative 4. We could try one by one. The positive number first. The positive number first. Anyone has tried this? 1 over 3. Okay, 1 over 3. So 1 over 3. So we check that this is 1, 6, 2, it's become 12 and 4. So it's true that this is our positive root. So we are going to have our PM is m minus 1 over 3, and then multiply with 3m squared plus 6m plus 12. Okay. Now if we want to find the root that's equaling this to 0, okay, so m1 is 1 over 3, and then this part here we are going to find. So we are going to get 3. Let me factor out this. Okay, so we have we could get the inside here taking the complete square, so we can write this as m squared plus 2m, supposed to be plus 1, right, to make it complete square. So we have m plus 1 squared, so we are going to have m squared or m plus 1 squared and a plus 3, right, plus 3 equal to 0. Plus 2m plus 1, yeah, plus 3. Okay, so m plus 1 squared is negative 3, which is going to be m plus 1 is plus minus square root of 3 of imaginary number. Okay, so we could have the m2 is the positive 1. So maybe let me write a little bit going to the left. So negative 1 plus square root of 3 imaginary number, and m3 is negative 1 minus. So alpha is negative 1 and beta is square root of 3. We are just focusing on the value. Okay? The plus minus will be later disappear with the Euler formula. So we could write down from this m1, m2, and m3 the general solutions. That is, the first one is nothing big deal. We just write e with power of the m and multiply with x, so x over 3. And plus, remember, m2 and m3, they will be our conjugate. So we are going to have e with power of negative alpha x. Alpha is negative e with power of alpha x. Alpha is negative, so it's going to be negative x. And this was c2 cosine square root of 3x plus c3 sine square root of 3x. Okay. So the more you have practice within this example, I think you will see the pattern on how to write the general solution. As long as you keep consistent, knowing the first case, the second case, the third case, and all the cases depends on the root. At the beginning, we are having this 2 roots, right? But we have now more roots that we can have combination. We can have the first case with the third case, and also we can also combine when we have the multiplicity. Then don't forget that we need to multiply with the x, or x squared or x cubed if we have more multiplicity. Okay. Okay, after this, we are going to move to the next technique, which is the undetermined coefficient. That is techniques for solving the non-homogeneous. So remember, all this part, the constant coefficients, it will work only on the homogeneous. Okay. This is the general solutions. Okay, the undetermined coefficient is actually quite simple. So let me give you a very summarized method. So I believe all the introduction here is already been explained before. So let me just write. First is the undetermined coefficient. this is to solve or solving non-homogeneous of a higher order of ODE, okay, of the differential equations. So let's look on these equations. Okay, this is non-homogeneous because the right side it has the 3e with power of 2t. Okay, so you could also guess that the independent variable perhaps t. Okay, perhaps t, because there's no other information. So we assume that the independent one is t and the dependent one is dy. Let the yp, this particular solution, as we also mentioned before, let this yp can solve the non-homogeneous. And yc, the complementary, or the one that solves the, let me just write that, complementary, okay, solutions, okay, and this yc is solving the homogeneous, right? So the homogeneous equation from the non-homogeneous, we could write this is y double prime minus 2y prime minus 3y equals 0, okay? And we know from the previous lesson that y is yp plus yc, right? And if we include or plug in this yp plus yc into our equations, we could see that this is can also solve non-homogeneous, right? I think we already did this before, but this is just to remind you. Okay. So step one, the process, okay, the process is we are going to solve the homogeneous. So let's the equations, let me write equal into 0. So how to solve this? This is the same as previous auxiliary, okay? So we are going to use m, the root, m squared minus 2m minus tiny n. So we get the homogeneous one. That's the first one. So take the auxiliary equations. So, and then we take this and saying that this is going to be having m1 is 3, m2 is negative 1. So this is yc, okay? This is yc. Yc is c1e 3t plus c2e negative t. Okay, now step 2. Find solution for non-homogeneous. Non-homogeneous yp. So y double prime minus 2y prime minus 3y equal 3e with power of 2t. Okay. Okay, now how do we solve this? We can solve this if we could say the right part is having some kind of e exponential, right? So it is very obvious if the solutions that we propose is also exponential. Because exponential, if you derive, it's also another exponential. You derive again, it's also exponential, right? You derive more and more, still exponential. So the most logical way that we can solve it, our proposed solution is y equals e something, right? Or e with power of 2t something, okay? So let's say our yp is equal to some constant a multiplied with e with power of 2t. Okay, so this is why it's called undetermined coefficient. We are having undetermined coefficient here, okay, that we are going to find when we solve this. And then yp, we are going to take from here, and we are going to see some equations over here, okay, as well. So we are going to check. Let me just derive twice for the yp. So derive the first one, the first derivative. This will be 2a e with power of 2t, and then the second derivative we get 4. Okay. Now we plug in all these things. So we plug in 4a e with power of 2t minus 2, and this will be 2a e power of 2t, and then negative 3a e 2t. We see that we are going to cancel this out, right? And we see that this negative 3a e 2t is going to have this similar form, right? So we could say that we could find this a, right? A is negative 1, right? So from this canceling, we can find that a is negative 1. So our proposed yp is negative e of power 2t. Okay, so we got yp, we got yt, and we are going to plus this 2. Okay. So step 3, remember that y is yc plus yp. Okay. So general solutions. So this part is yc, this is yp. Okay? And that's the principle. And that's the principle. So of course, the type of questions or the type of problems, it depends on this right side. So you could imagine what kind of functions that when we derive, maybe will be appearing at itself. You could also think sine and cosine. If we can make out those sine and cosine, we could also try to use the same thing here. I will add additional notes about this, okay? Because sometimes when we find a yp, if we can, or if we have, example, if we have in yc the same component as yp, then perhaps we need to add with another coefficient to make it more linear independent. I will add notes to this. And I think that will be the last part before we end the course. Okay, some notes. Okay, some notes. let's say we have this one. Okay. Now I changed a little bit the questions. So the homogeneous is still the same. So the YC is still the same. Same equation on the left for homogeneous. But if we look here, and we said that our YP will be something about this, but it's also out in our homogeneous. So we need to do something about this. So if we let undetermined coefficient if YP is something A, E, negative T, but this part is the same with this, okay? This is a problem. So A, E with power negative T cannot be YP. So we need to check, okay, we need to check another YP that is linear independent. And of course, I believe we already also discussed in the previous session that when we add T in the front, that should solve the case. Right? So we could check that as our YP. So we could check YP A T with power of E with power of negative T. We could check the first derivative. And check the second derivative. The second derivative I will directly write negative 2A E negative T plus A T E negative T. And then by taking this into our equations, we are going to have, let me write here, y double prime minus 2y prime minus 3y equal 3e negative t, and plug in all these components. Okay. And I think we can solve this. So we can cancel this with this, right? So we could have AT minus 2 minus 3. So we have plus AT. So we have minus 3y AT. Yeah, I think we can solve this. So AT and equal 3e negative t. And we can solve this at the end. Oh wait, I think I made a mistake here. We can cancel this out. Minus 2AE minus ATE. I think I have some problem here. Okay, let's just continue later. Okay, but I believe you can solve this. Okay, and find the A. think I will end up in here. So we'll continue this method next Tuesday. We're going to have more examples. And if we finish, then we will go to the next step. There will be no feedbacks before today. So see you next Tuesday. So basically, undetermined coefficient is we are just proposing our something with the equation and with a constant and put that to the equation.